Almost every single day we check the weather forecast. It's just part of our routine, right? It tells us if we need a jacket, if we should bring an umbrella. But what if the entire way we predict that weather was about to be turned completely on its head? Let's dive into how this AI revolution in forecasting is really starting to take shape.
So it all boils down to this one huge question. Can artificial intelligence, a technology that's all about learning from data and spotting patterns, actually do a better job than the gigantic physics-based methods we've relied on for more than 50 years? I mean, we're really setting the stage for a classic showdown here, the reigning champ versus a totally new kind of challenger.
Okay, so here's our game plan for this explainer. First, we're going to meet the reigning champ, the physics-based forecaster. Then, we'll bring in the data-driven challenger, AI. After that, we'll look at how they're kind of working together right now in a hybrid model. And then, we get to the main event. Can AI actually take over the whole show? Finally, we'll wrap up with what all this means for the forecast you see every day. All right, first things first. Let's get properly introduced to the current undisputed champion of weather prediction. Seriously, this method has been the gold standard for decades. It's a true titan in the world of atmospheric science. It's called Numerical Weather Prediction, or you'll often just hear it called NWP. And at its heart, NWP is all about physics. It literally takes the fundamental laws of thermodynamics and fluid dynamics, the actual rules that govern how our atmosphere works, and uses them to build a mathematical model of what's going to happen next. So how does this beast actually work? Well, first, it just inhales a staggering amount of data from satellites, from weather balloons, from sensors all over the ground. Then it cleans all that raw data up and shoves it into a supercomputer. And that's when the real work begins. The computer starts crunching these incredibly complex physics equations to simulate what the atmosphere is going to do. Finally, that raw simulation gets polished and refined into the forecast that pops up on our phones. But even the champ isn't flawless. NWP needs an absolutely insane amount of computing power. We are talking about building-sized supercomputers. It also really struggles with the small-scale stuff, like the incredibly complex physics happening inside a single cloud. And, this is a big one, it can have a really hard time predicting those rare, extreme weather events that just don't play by the usual rules. And these, right here, are the cracks in the armor that have opened the door for a new challenger. And this challenger, well, it comes at the problem from a completely different direction. It doesn't start with the laws of physics. Nope. It starts with data. Lots and lots of data. And this right here is the fundamental difference between them. NWP is what we call model-driven. It basically says, hey, I know the rules of physics that run the atmosphere, so I can calculate what's going to happen. But AI is data-driven. It says, I've looked at decades of past weather, I've seen these patterns before, so I can predict what's most likely to happen next based on what I've learned. It's two totally different philosophies. This quote from the source material just nails it. Instead of solving these equations from the ground up every single time, AI models are trained on decades upon decades of historical weather data. They just get incredibly good at recognizing all the subtle, super complex relationships between pressure, temperature, and wind that might be too chaotic for a pure physics model to see perfectly. But here's the thing. Right now, it's not actually an all-out war between these two. It's more like an alliance is forming, where this new challenger is making the old champion even stronger. Let's see how that works. So one of the first jobs AI has taken on is helping out with something called data assimilation. The best way to think about it is like this. AI is the ultimate preprocessor. Before the big physics simulation even kicks off, AI models can go in, intelligently fill in any gaps in the weather data we have, and stitch it all together more efficiently. This gives the old NWP model a much cleaner, more accurate starting point. And on the other end, AI is also a fantastic editor. So after the NWP model has done its huge hours-long simulation, the raw output can still have some known mistakes or biases. Well, AI models are trained to spot those specific errors and correct them, basically cleaning up the forecast at the very end to make the final product that we see that much better. And the results of this team-up are, well, they're pretty stunning. Get this. One study found that by using an AI model to clean up the precipitation forecast from a traditional model, they cut the error rate by a massive 63%. I mean, that's not just a little improvement, that is a total game changer. Okay, so all of this success naturally leads to the ultimate question. If AI is so great at helping out, could it just do the whole job by itself?
Can we get to a point where we have end-to-end AI forecasting that completely replaces the old physics-based champ? This is the title fight. And believe me, some serious heavyweight contenders are already in the ring. You've got models like Pangu-Weather, which was trained on almost 40 years of global data, and it's already proving that it can be more accurate than some of the top traditional systems out there. And then there are others, like DeepMind's GraphCast, which is showing incredible skill at making these really reliable 10-day forecasts. In fact, it's already outperforming the classic models on most of the key measurements. But maybe the biggest knockout punch, the single greatest advantage, is just pure speed. Take NVIDIA's ForecastNet. It can generate a forecast thousands of times faster. What used to take a giant supercomputer hours to do can now be done in just a few minutes on a modern GPU. This is the new face of forecasting. But hold on. Before we go and declare a new champion, we have to pump the brakes and acknowledge that AI has its own set of hurdles. One of the biggest is the black box problem. The AI can give you a fantastic answer, but it can't always tell you why it came to that conclusion. Its predictions are also completely tied to the historical data it was trained on. So if a rare extreme weather event comes along that it's never seen before, it can really struggle. So, after weighing the raw power of the reigning champ against the incredible potential of the new challenger, what's the verdict? What does the future of your weather forecast actually look like? The thing is, the future probably isn't about a knockout. It's about a powerful collaboration. The best way to think about it is that we're combining two different ways of knowing. You have the deep, first principles understanding of physics from NWP, and you combine that with the experience-based pattern recognition of AI. One gives you the solid, reliable foundation, the other gives you the speed and the nuance. And together, they can create a forecast that's way more powerful than either one could ever be alone. And that really just leaves us with one last thought to chew on. As these amazing technologies come together to give us faster, more accurate, and more detailed predictions, especially for extreme weather, the question really starts to shift. Our forecasts are, without a doubt, getting smarter. But the real question is, are we getting any wiser about how we use all that incredible information to prepare, to adapt, and to protect ourselves?